Any trouble with 1? We're good with 1? Okay. Number 2? We're good with 2? Okay, number 3? Number 3. So the basic function x squared has a given range of 0 to infinity. So if you look at, this is x squared, and the range is going to be 0 to infinity. Those are the y values. Using interval notation, determine the range of the function negative x squared minus 30. What does the negative in front of the x squared do to the graph? Flips it upside down. Okay, reflects it across the x-axis. What does the minus 30 do? It brings it down 30. So here is the new graph. What is the range? Negative infinity to 30. So that would be B. And the 30 is inclusive. How do we know that the, or sorry, A, negative 30. How do we know that that negative 30 is inclusive? Yeah, when it is part of the function. If you plug in 0, you do get negative 30. And in general, if they don't tell you that it's not part of the function, it will be. Okay, 4. That one should have been pretty easy, right? Plug negative 4 into G, and you get error, right? So, yeah, you plug negative 4 into G, and that can't happen. So it's error, so the answer should be E. Right. So that's what you have to be careful with. Can you put G into F? Yes, and it turns into X. But the domain of a composition is the domain of the first one combined with the domain of the entire one. And the entire one has no domain restrictions, but G does have a domain restriction. So the answer is E. Note the order. I love how they give you all those hints. Okay, number 5. So number 5, we have to look at, so we have F, we have G, and we have F of G. Only 2 of those affect the domain of F of G. What are they? G and the end result. Does G have any domain restrictions? No. When we put G into F, I get the square root of 2x minus 1, which has a domain restriction of 1/2. So the only domain restriction is 1/2, so E is the answer. And notice F does have a domain restriction. What is the domain restriction of F? 1. But that's not part of the answer. So G is all real numbers. F is x is not allowed to be 1. And F of G, x is not allowed to be 1/2. Right? This one does not come into play when we're doing F of G of x. It's the domain of the one on the right intersected with the domain of the resulting equation. Oh, sorry, I did that wrong. Yeah, it should be greater than or equal to 1/2. There you go. Yeah, I got my domain restrictions mixed up. So yes, C. I was just testing you guys. Okay, 6. I cannot invert 6. Why not? It's a parabola. And technically you can invert anything, but if the inverse is not a function, then we don't want it. So the inverse of f is not a function, so the answer is E. Okay. 7. Any questions on 7? Good. Okay. 8. Any questions with 8? No? All right. 9. Oh, back to 8. So we have a 5th degree polynomial, x to the 5th. And we know that x equals I is one of the roots, and x equals 1 is one of the roots with the multiplicity of 2. Okay? The graph of the function will have 2 x-intercepts, true or false? Well, I have x plus I, x minus I, and x minus 1 squared. What else has to happen? Well, there has to be another factor, right? What do I know about that other factor? It's not imaginary. Why not? Every imaginary factor has to have an imaginary complement, a conjugate. So it can't be imaginary. Can it be 1 or x minus 1 again? Is it possible for this last one to be x minus 1? No, why not? They told us it only has a multiplicity of 2. So this other factor has to be a real number, and it can't be 1, which means it's true because the graph has to hit the x-axis somewhere else. If we were to graph this, we have an x to the 5 x to the 5th graph, which looks something like that. We have a bounce at 1, and we have an imaginary set of roots somewhere, so it probably looks something like this. Here are my imaginary roots. Here is my multiplicity of 2, and then there must be some other point that it hits the x-axis. Now, it might be on the other side, so the graph might look like this. But in either case, it has to hit the x-axis twice. Okay, number 9. So number 9, you're going to use synthetic division and simplify it down to a quadratic. And then you factor that quadratic, and I believe the answer was E. Is that right? Because you can write it as a product of linear, or sorry, you cannot write it as a product of linear factors, and there is only one x-intercept, and that is 2. The other 2 are imaginary. Okay, 10. So number 10, I'm just going to do this one. Negative 2x over x times x minus 10. So the x's cancel. What does that mean? What happens at x equals 0? There's a hole. Okay. X minus 10 does not cancel. So what happens at x equals 10? It's a vertical asymptote. And I have a negative 2x over an x squared, which simplifies down to negative 2 over x. Does that have an HA? Yes. The bottom is bigger than the top, so the HA is at y equals 0. What if the top and bottom are the same power? The HA is just the ratio of the coefficients. What if the top is 1 bigger than the bottom? Then you have a slanted asymptote. How do you find a slanted asymptote? Just do division and throw out the remainder. Okay. So, A, the graph of the function has 1 horizontal asymptote and 2 vertical asymptotes. False. It only has 1 vertical asymptote. Can a graph have 2 horizontal asymptotes? It actually can. Not a rational function, but you could have a graph that looks something like this. but that won't happen in this class. As x gets bigger, f of x gets bigger. True or false? False. As x gets bigger, f of x does what? It doesn't get smaller. It approaches 0. There's an HA at 0, so the further to the right we get, the closer we get to y equals 0. D, the domain of the function is everything but 0. That's false. What are my two domain restrictions? 0 and 10. As x approaches infinity, f of x approaches 0. That's true. The graph of the function has a horizontal asymptote at -2. No, it's 0. All right. Who wants to see 11? Probably everybody, right? Okay, so we have x to the fourth minus 4x squared is less than or equal to 0. That is x squared times x minus 2 times x plus 2 is less than or equal to 0. What are the important numbers for this function? And the important numbers are wholes, vertical asymptotes, and x-intercepts. Basically, what happens on the x-axis that is special? And so the three things that can happen is you could have a hole, you could have a vertical asymptote, or you could have an x-intercept. In this case, it's not a rational expression. It's just a regular x to the fourth function, so there are no holes and there are no vertical asymptotes. All I have to worry about are the roots. So on my number line, I have -2 as a root, 0 as a root, and +2 as a root. And essentially what I need to do is figure out what happens over here. Anything left of -2 has to be entirely above the x-axis or entirely below the x-axis. It can't switch. The only places it can switch from one side to the other is at a hole, a vertical asymptote, or a root. So I need to plug in some number to the left and figure out what the sign is. So I'm going to plug in -3. -3 to the fourth is 81 minus 4 times 9. And all I care about that number is that it is positive. 81 minus 4 times 9 is positive, so this piece is positive. Okay. Now I look at this piece. Easiest thing to plug in is -1. So -1 to the fourth is 1 minus 4 times 1 is negative. Okay. Now we need to look at this piece, and I'll plug in 1. 1 minus 4 times 1 is negative. And then we look at the last piece. I'll plug in 3. 81 minus 4 times 9 is positive. So now I know what the graph looks like. It looks like this, which you probably could have figured out if you thought hard enough about it. We have the root of 0 with a multiplicity of 2. We have a positive x to the fourth graph, and we have roots at -2 and at +2. Okay, so when is this graph less than or equal to 0? What is the interval? It's going to be from -2 to 2 with brackets. Okay, what if there was no equal to right here? How would that change it? The outsides would turn into parentheses, but something else changes. 0 is no longer one of the answers. So it would be -2 to 0 union with 0 to 2. Okay, now this one you can actually graph and get a pretty good sense of what's going on. So if I typed in x to the fourth minus 4x squared and I graphed it, that's actually really easy to see. But a lot of times when they throw these questions in the final, you have to change your window in order to see it. And if that's the way you prefer to do it, then go ahead and do it that way. There's no reason why you can't, especially on how easy this one was. All right. Number 12. Any questions with 12? That one should have been pretty simple. Okay, 13. Anybody want to see 13? No? All right, 14. That one's pretty easy. Okay, 15. And 16. Oh, you want 15? 15? So we need to use the product rule. So the logs have the same base. So I get the ln of 6x, which is 3x times 2, is equal to 3. This is base e. I only have logarithm on one side, so I need to convert to exponent. E to the third equals 6x. Divide by 6. And I get x is e to the third over 6. Now, do I have to worry about plugging this back in? Yes, because the original problem had logarithms. So, if I plug in e to the third over 6, do I create negative or 0 inside a logarithm? No, e to the third is a positive number, so it totally works. The answer is A. So the product rule, let's say I had log base 5 of x plus log base 5 of x minus 3 minus log base 5 of x minus 1. So as long as all the logarithms have the same base, you can smash them all into one log. So anything that is positive lands in the numerator. So x and x minus 3. And anything that's negative lands in the denominator. So the product and quotient rules say if you have multiple logarithms that are added and subtracted together that have the same base, you can write them as a single logarithm using multiplication and division. And the reason that works is if I had x to the fourth times x to the third over x squared, if they're multiplied, we add the exponents together. If they're divided, we subtract the exponents. So this is x to the seventh over x squared, which is x to the fifth. These combine together using addition, and these combine together using subtraction. That's a little bit of a simplified explanation, but basically that's what's happening. Okay, do you want to see the partial fraction decomposition? Yeah. So 3x plus 1 over x times x minus 1. So I have a over x and b over x minus 1. This one needs an x minus 1, and this one needs an x. So I get ax minus a plus bx is equal to 3x plus 1. So my first equation is negative a is equal to 1, and a plus b is equal to 3. You can plug this into your calculator, but in this case, we know that a equals negative 1. And then negative 1 plus b is 3, so b has to be 4. And then it asks, what is the numerator if the denominator is x plus or x minus 1. So it wants the b value, which I calculated at 4. Did I get it right? D. Okay. Number 18, I'll do that one. Negative x squared plus y equals 2, and x squared plus y squared equals 4. We're just going to add the two equations together using elimination, and I get y squared. Wow. Let's try that again. Y squared plus y equals 6. So y squared plus y minus 6 equals 0. Y minus 2 and y plus 3. So y equals 2 and negative 3. And that's what it wants. A. What if it wanted x? Then you'd have to plug both of those back in, and you would get two copies of x's, which would be weird. So you would, if they wanted the x's, you would do x squared plus 4 equals 4. Subtract 4 and you get x equals 0. And then x squared plus 9 equals 4. You'd subtract 9 and you get x squared equals negative 5, which doesn't exist. So it turns out there's only one x, it's 0. Oh. Oh, so the answer is B. Oh, that's tricky. Yes. So the equation spit out two y values, something comma 2 and something comma negative 3. Well, they're being really tricky because when you plug this in, and I'll plug them into the top equation, it'll make a little bit more sense. So if I plug this in, negative x squared plus 2 equals 2. Well, 0 is the only number that makes that work. So the answer is 0 comma 2. But they're being tricky because when I plug in negative 3, I'm going to add 3 and then times by negative 1, and I get x squared is equal to negative 5, which doesn't exist. So that was actually a red herring. Tricky. I didn't think they'd do that to you, but they did. So anyway, the answer is B. Sorry about that. Okay, a linear system of equations. Oh, that's easy, right? Plug that into your calculator, and oh, was it D or E? Did it have one solution? What was the answer? No solution. Okay, good. Um, so on D and E, a system has an infinite number of solutions given by one of the. If you have infinite number of solutions, then oh my goodness, that's so terrible. What has to happen in your augmented matrix in order to have infinite solutions? Nope. If you have that 1 0 0 pattern, 0 1 0, then it has one solution. No solutions, which is this one, had a bottom row that said 0 0 0 1, which basically says 0x plus 0y plus 0z is equal to 1, which is impossible. What about infinite solutions? The whole bottom row will be zeros, which is 0 equals 0, which is always true. The tricky thing is, apparently they want you to put together what the solutions are, which is a total mess. Anyway, you have to build it out of the numbers that are above the row of all zeros. So maybe I'll show you, just in case this happens. All right, I'm going to edit. I'm going to do a 3 by 4. And plug these in. Okay. Now, obviously, um, if we times the middle row by -3, then the middle row and the bottom row are equal, which would be infinite solutions. Or sorry, they're not equal because the answers are different. The first one would be -3, -3, 6, and the bottom one is -3, -3, 9. So I'm going to change this and put the -3 right there, and this will make it infinite solutions. And I'll show you what they're talking about. So I need to do my reduced row echelon of matrix A. So see how I have these equations that are left over? I have x minus 5y equals 7, and then y plus z equals -3. That's where those equations are going to come in. So, I really hope they don't do this to you. Anyway, you have to create a dummy variable, which is called a, and then use all the information to solve them together. But that 3 and -2 minus 3a and 5 plus 15a will show up inside of here, which, in my opinion, there's no reason to even care about that, but whatever. All right, given matrix A and a 3 by 3 identity matrix I. What is a 3 by 3 identity matrix? 1 0 0 0 1 0 0 0 1. Is it true that A times I equals A? Yes. So A is a 2 by 3, and I3 is a 3 by 3. So if we take a 2 by 3, oh, sorry, 3 by 2 times 3 by 3, that doesn't work. I'm not taking this test. So you cannot multiply that by I3. You could multiply it by I2, and then it would be true, but they gave you the wrong equation, or the wrong matrix. All right. Do we need to see number 1 on the multiple choice? We've done lots of these. The first story problem? No? Okay. Number 2, inverse. Any questions on that one? All right. So, the original function is r of, wow, that's not an r, r of t, which is 2 square root of t plus 10. So the original function turns a time into a revenue. And by the way, in terms of business, what does revenue mean? It's everything that comes in. So you run a company, you buy lots of stuff, and you sell it. Revenue is how much money comes in. Cost is how much you pay out. And the difference is called the profit, hopefully. Right? If it's not called profit, then something's wrong. Yeah, it's called loss. So revenue is everything that's brought in. Cost is everything that goes out. And the difference between the two is called the profit. And we really shoot for a profitable business. We want that profit to be positive. So In context of this problem, explain in words what the input of the function R inverse represents and what the output of the inverse represents. So the original function inputs time and spits out revenue, meaning after this many days, after T days, the company makes R thousands of dollars. The inverse function, R inverse of T, oops. So R inverse of T is just backwards. Revenue gets turned into time. So the input is, if the company has made a specific amount of revenue, then how long did it take to get there? So revenue is the input and time is the output. Does that make sense? Okay. 3. Anyone need help with 3? Should have been pretty straightforward. We've done a bunch of those. All right. And 4. Yeah. So is this on 4? So on 4, you can either use, oh, it's right there. So yeah, if you use the graph, draw the graph, and then, so if you like to find the maximum, you're saying? Yeah. Yep. Just say what it was that you did. And do you want me to do 5? 5 is a little tricky because they did something that we're not used to. And it's a lot harder to do if you don't have the reference sheet. So let me find the reference sheet for this test. Hang on just a second. Okay. Come on. There we go. Okay. So the Richter scale magnitude of an earthquake is given that, where I is the intensity. Oh, I cut it off, but that's an I. And remember, I sub 0 is 10 to the 4.4. And then the energy released is given by that silly equation, which we'd never seen before, right? So fill in the following statement. The intensity of earthquake A is blank times more than the intensity of earthquake B. So I have a magnitude 4 and a magnitude 3. I need to figure out what the intensity is. So 4 is equal to log base 10 of I over 10 to the 4.4. So 10 to the 4th is equal to I over 10 to the 4.4. So now I multiply by 10 to the 4.4. If two numbers have the same base, what do I do to the exponents? Add the exponents, so I get 10 to the 8.4. That is the intensity of an earthquake with magnitude 4. Okay. I do exactly the same thing with a 3. So this becomes a 3. And what is 10 to the 4.4 times 10 to the 3rd? 10 to the 7.4. You can do, that's the old, yeah. You can do it that way. But on this test, they gave a different one. That's the energy equation. So you can use the energy equation from the book, but then you have to convert this energy equation into the inverse identity, or inverse intensity. So anyway, this one's a lot easier to use, which is silly. Well, I mean, use whatever one they tell you to, which is why we had so many problems when we figured it out. So this is the intensity of an earthquake with magnitude 3. How much more intense is the 4 than the 3? Well, how does 10 to the 8.4 compare to 10 to the 7.4? It's 10 times more intense. What does earthquake intensity mean? I don't know. I, I don't know what it means. I know what energy is, but I don't know what intensity means. So, for any two earthquakes A and B whose Richter scale magnitude differ by 1, will the earthquakes have the same answer? So, what it's saying is, if I were to change this into a 5 and this into a 4, would these answers still be 10 times off? Yes, they would be. Okay, and then C, what is the energy released? Well, energy is simply this. So energy is 2.5 times 10 to the 4th times 10 to the 1.5 times 4. So 2.5 times 10 to the 4th times 10 raised to the 1.5 times 4. So the energy is 2.5 e to the 10th. And the energy of the other one is going to be that. And how do I... So earthquake A is approximately blank times. How would I figure that out? How do you compare the size of one earthquake to another? Divide them. So I want to do 2.5 e to the 10, e10 divided by the answer. And a magnitude 4 earthquake releases 31 times more energy than a magnitude 3. Okay. For any two earthquakes A and B whose Richter scale differs by 1, will we have the same result? Well, let's try one. Let's do 2.5 times 10 to the 4th times 10 raised to the, let's try a 6 and a 6 and a 5. 2.5, no, 1.5. 1.5 times 6, and then we'll divide that by this same, oh wait a minute, I don't want to do that yet. So divided by, we'll do this same equation to the 5th, and we'll see if we get the same answer. Yes. Now, I don't really understand what's going on here. I have no idea what earthquake intensity means. But if there is a question like this, they will give you the formulas. I didn't print off the formulas because I didn't think you were going to need them. But turned out that you did. Okay.